This is Trigonometry Unit 1-1 formulas. We'll start off talking about the coordinate plane, which is, if you take an x-axis, that's the horizontal one, a y-axis, that's the vertical one. It divides a plane or a region up into 4 quadrants. The stuff that's above the x-axis and to the right of the y-axis is called the first quadrant, or quadrant 1. Also, we talk about ordered pairs. And they're called ordered for a reason. The reason is x comes first. The x coordinate comes first and then the y coordinate. And if you think about it, all the coordinates in the first quadrant are going to be positive x value, positive y value. The second quadrant will go in a counterclockwise direction. The second quadrant is above the x-axis and to the right or left of the y-axis. This is quadrant 2. And the order pairs here will be negative, positive. Negative x, positive y. If we go below the x-axis and to the left of the y-axis, we get quadrant 3. And all your ordered pairs here are going to be negative x and negative y. Quadrant 4 will be to the right of the y-axis, still below the x-axis. Now you're going to have a positive x coordinate, a negative y coordinate. Then, distance formula. We can talk about 2 points in the plane. If I just pick a couple random points, and we want to talk about the length of the line segment that connects them, we call this coordinate x1, y1. Call this point x2, y2. Then you can construct a right triangle, and this length, or this, and remember from the Pythagorean theorem, it says that c squared is equal to a squared plus b squared, and that's true for any right triangle where a and b are the legs of your right triangle. C is the hypotenuse, and if you look at this, the distance between these 2 points is the hypotenuse of a right triangle. So the length of this leg is going to be x2 minus x1, or x1 minus x2. We're going to square it, so it doesn't matter what order we put them in. We can say this is y2 minus y1 for this other leg. So the distance is going to be the square root of x2 minus x1, quantity squared, plus the quantity y2 minus y1, quantity squared. That's your distance formula, and that's where it comes from. We can also talk about the midpoint. The midpoint is the point that's halfway between these 2 points, and if you remember, the average of any 2 numbers is halfway between those 2 numbers. We denote the midpoint as x bar, y bar, and it's going to simply be the average of your x coordinate, so x1 plus x2 divided by 2, and the average of your y coordinates, y1 plus y2 divided by 2, and that gives us the midpoint. Now we're going to talk about the graph of the equation 2 variables. If we think about a linear equation, say for example y equals some mx plus b, well, a linear equation is linear because it's a straight line graph, has a constant rate of change. This point here would be 0b, and this would be a positive m, positive slope. The coordinate, or this line describes all the ordered pairs that make this equation true. One of the things that we do in this textbook is, given a rule, you're asked to fill out a formula table for it. For example, if you say y equals x squared minus 2, then they might give you an xy table. If we put in a few points, if we let x equal 0, this will be 0 squared minus 2, so you get negative 2. If I let x equal, say, 3, then this would be 3 squared minus 2, which is 9 minus 2, which is 7. If I let x equal, say, negative 2, then this would be negative 2 squared minus 2. That's going to be negative 2 squared is positive 4. 4 minus 2 is 2. And that gives you a few ordered pairs on the graph of this curve. Intercepts are where we intercept or cross an x-axis or a y-axis. This point here is called the y-intercept. This point where we cross or intercept the x-axis is the x-intercept. I don't have a special letter for the x-intercept, but it's going to be the x-intercept. The y-coordinate is going to be 0. What's important about intercept is, remember, when you have a y-intercept, the x-coordinate is 0. When you have an x-intercept, the y-coordinate is 0. Circles. If you have a circle with center at the point H and K, a radius of R, then the equation of that circle is going to be x minus h. That quantity is going to be squared, plus y minus k. That quantity is going to be squared, and that's going to be equal to r squared. This is what's called the standard form of a circle. We also need to be able to find the equation of the circle, and we'll talk about that whenever I do the problem section. Symmetry. Well, best way I know of explaining symmetry is with some pictures. If I draw this graph, and this is meant to be symmetric with respect to WRT, the x-axis. Also notice that if you were symmetric with respect to the x-axis, it is not a function. That comes a little bit later. But if we can make the x-axis the spine of the fold, these two halves will meet up with each other exactly. If you have symmetry with respect to the y-axis, that's going to be graphs that look something like this. This is symmetric with respect to the y-axis. Now the y-axis is the spine of the fold, and if we could fold it up making this the spine of your fold, these two halves would match up exactly. Algebraically, if you replace in a function f of negative x, if you replace x with negative x, you get the exact same value. You have symmetry with respect to y. For example, this could be the graph of, say, y equals x squared plus 2. Then this would be the point, say, 2 squared is 4, 4 plus 2 is 6, so that's going to be 2, 6. Because it's symmetric with respect to the y-axis, we know that this point over here, when I replace x with negative x, when I replace 2 with negative 2, I'm still going to get the same y value. It's still going to be 2, 6. The other type of symmetry we talk about is symmetry with respect to the origin. Now, symmetry with respect to the origin is going to look something like this. Classic example is y equals x cubed. This will be the point, say, 2, 8. This will be the point negative 2, negative 8. Now, if you could fold this across the origin, these two halves are going to match up exactly. Algebraically, if you replace x with negative x, and you get the negative of your original y function, or of your original function, then you have symmetry with respect to the origin. Symmetry with respect to the origin. Now notice, when I replace x with negative x, when I replace 2 with negative 2, I get the negative of my original y value. 8 and negative 8, they're opposites. Okay? And that's pretty much the formulas out of Unit 1.1.